with cones today. Find the volume, lateral surface area, and total surface area of the following cones. So basically, the things we would be asked for in this section about three-dimensional space, surface area, lateral surface area, and volume. We have all our formulas right here that are on your sheet. And the only units, the only things we have to consider the dimension of this thing, the altitude, which is the distance from the base to the tip of the cone. Whether the cone is sitting upright or it's upside down, kind of like an ice cream cone, whatever, there's going to be a base on the bottom that extends up to a point on top. The altitude is that dimension. So when it says altitude, it's specifically talking about the distance here. That's the altitude. The slant height is just what it sounds like. You're on the edge and you go at a slant to the tip of the pyramid, to the tip of the cone. So slant height, when they talk about that, S, in our picture, we're going to envision slant height being here, and it should be the same as this over here. Slant height's the length from the edge of the base up to the tip of the cone. And then finally the radius, we're going to have a circular base on a cone. Okay. The radius is the distance from the center of the circle out to the edge. Right? So the three dimensions should be given to us when we're dealing with a cone. The only thing they might not give us, one of those three. So they might not give us the height or the radius or the slant height, but if they give you any two of the three, this is 18 inches over here as well, right? This is a right triangle. So we could use the Pythagorean theorem maybe to find a missing dimension. 10 squared plus 15 squared should equal 18 squared. Pretty close. That's 225, that's 100, that's 324. So it's off by just a smidge, but pretty close. They're obviously rounded a little bit on this one. All right, so with all that in mind, once the volume, lateral surface area, total surface area of the following cone, our formulas are exactly right over there, so we just do what they tell us to do. So I identify what I know. I know my height is 15 inches. I know my slant height is 18 inches. I know my radius is 10 inches. So you simply identify what the dimensions are, then apply the proper formula, use a calculator to calculate things. So if I'm doing the lateral surface area defined as L equals pi RS. What the lateral surface area represents would be the area of the cone up here. It's not the area of the base. So imagine an ice cream cone, right? Like one of those sugar cones that comes to a point, right? The cone itself has surface area. There's a hole on the top, so there's no area on top, right? So kind of imagine an ice cream cone with a hollow top. That's what lateral surface area is. If you put a cookie on top of that ice cream cone, I know we're getting near lunch, I'm sorry about that, but if we put a cookie on top of our ice cream cone, now it does have a base, that'd be the total surface area, the area of the cookie plus the area of the cone. And then volume would be how much ice cream fits inside of it. All right, so that kind of visualize what's going on here. So, lateral surface area is pi times r times s. We're going to use the pi button on our calculator to calculate, but pi stays pi. R is 10 inches. S is 18 inches. These units are all inches, so lateral surface area, inches times inches makes inches squared. My calculator can calculate for me, so second pi, so get the pi button, times 10 times 18 gets me a lateral surface area of 565.49. If I go a couple decimal places, it doesn't specify, right? So since it doesn't specify a couple decimal places, it's fine. So my lateral surface area is 565.49 inches squared. Again, as far as showing work on a homework, identify the useful dimensions, identify the formula you're going to use, apply the formula, calculate the formula. I want to see all that stuff on your paper each time on all these problems. Total surface area. Notice the total surface area is the lateral surface area, pi rs, right? And then pi r squared is just the area of the surface. So it's just the edges area added to the base. So for my total surface area, it's pi rs plus pi r squared. If I wanted to, I could just put 565.49 there. but I can also do pi times 10 times 18. Pi r squared, once again, r equals 10 inches. What does r squared equal? 100 inches squared, right? So we can evaluate over here, once we know r, we can figure out r squared real easily. So this is just going to be plus pi times 100. So I can get it again to a point where I can just evaluate it in my calculator. So if I do pi times 10 times 18 plus pi times 100, I get a total surface area of 879.65. This is also square inches. Whether it be lateral surface area, total surface area, any type of area is always going to be square units in your final answer. Okay, you write the formula, you substitute the dimensions into the formula, you use your calculator to calculate, you write your answer, round to the nearest, whatever they tell you to round to. If they don't specify, go a couple decimal places. Finally, they asked me to find volume of this. Volume formula is 1/3 pi r squared h. So I'm going to write the volume formula down. Volume equals 1/3 pi r squared h. 1/3 is 1/3, pi is pi, r squared, once again, is 100, and h is equal to 15. We have a simple formula there. Just like the sphere formula from yesterday, there's a fraction times all this stuff. Do the divided by 3 in the last phase. So 1 times pi times 100 times 15 divided by 3. So it goes like this. First of all, can everybody see 1 doesn't matter? So I don't have to type 1. If I do, it doesn't matter. So I'll just roll because it's there. So 1 times pi times 100 times 15 divided by 3. Comes out to 1570.796. So if I'm rounding nearest to 2 decimal places, that comes out to volume equals 1570.80. Volume is always cubic units because r squared is inches squared times inches makes inches cubed. So 1570.80 inches cubed would be our volume of this cone. One thing I didn't mention, because we're using our calculator to calculate, but sometimes 3 goes into 15 5 times. That happens sometimes where you can actually reduce it. If I did that reduction, notice I would just have 1 times pi, 1 times pi times 100 times 5. You get the exact same answer. But again, if your calculator is calculating it for you, it's not required to reduce things. The whole purpose of reduction is to make things simpler for you. Calculator's making it simple enough. So I wouldn't concern myself with that type of thing if I were you. But if you want to know that it's possible, you're allowed to do it. There's no harm in doing it. Right. So that's basically how you find all this important measurements for a cone. Lateral surface area, and volume. Apply the appropriate formula after you've identified the dimensions of concern. And again, there's a possibility on some of the problems where they only give you 2 of the 3, the Pythagorean theorem would have to be used. Hypotenuse squared equals leg squared plus leg squared in that scenario.